introduction to C and conditional loops and operators, and array and pointers we are also completed, and functions and strings, memory and storage classification, introduction to embedded systems and microcontrollers, MPLab IDE, XCB and PICSIMLab, introduction to various peripherals of PIC16F877A, and interfacing various peripherals of PIC16F877A, and given multiple quizzes which is in the course provided by the Emertex technologies. Yeah, this course we are going to cover the contents like introduction of microwave oven and project requirements and microcontroller and PICSIMLab and CLCD, matrix keypad, MKPay, and interrupt service routine ISR, and timer, and project implementation demo. Yeah, these are all covered by in this module. Coming to the concept of embedded system is a combination of any hardware and software which is intended to do a specific task. We all know that, the embedded system is in a microwave oven, works as a command device. A general purpose system is used to perform large number of tasks, whereas an embedded system is used to perform a specific task. So coming to the types of embedded systems, we have 4 types. The first one is standalone system, and the second one is real-time system, and the third one is networked system, and the fourth one is mobile system. And the components of embedded systems, we use the components like microcontroller, microprocessor, and the core processing unit. They call the core processing unit. And the coming to memory, RAM, ROM, flash, stores program code and data. Memory, we use that RAM and ROM flash. These are stores program code and data. And coming to input and output devices, it senses the data and switches, display, and act like actuators. And power supply and clock circuits. It provides stability and synchronization. And communication interfaces like SPI and I2C and UART for data exchange. And types of embedded systems, we have networked embedded systems, communication with other systems over a network. Example, we choose that smart home devices. And the real-time embedded systems respond within strict timing constraints. Example, airbag system in vehicles. These are the examples for the types of embedded systems, networked embedded systems and real-time embedded systems. And coming to the next slide, components and memory in embedded systems. We have in components like in embedded systems, core components are MCU, microprocessor, microcontroller unit, and memory, input and output devices, and software. In this, RAM is a temporary and ROM is a permanent device, and flash is rewritable and it is non-volatile. And microcontrollers and data sheets. Coming to the microcontroller data sheets, MCU equal to mini computer with CPU, RAM, and input-output devices. And data sheets describe architecture, pin configuration, memory map, and timers. And essential for accurate and efficient programming. These are all efficient used in microcontroller for efficient programming.
Project objective: simulate a real-world microwave oven system using PICSIMLab and replicate key microwave oven components, cycles and operations, and power on or off, program selection, grill function, convection or baking, and micro start. These all are the functions which are we covered in the project. These are the functions, and the last one is door status and completion alert. And that's it about the project objective. Yeah.
And these are the software tools we used in this project. And coming to the next slide, it's a block diagram of the microwave oven. In the middle of the block diagram, we have the microcontroller, is the brain of the computer, and it operates several operations in this microwave oven project. It operates a fan, for heat sink to remove the hot air to outside, and display modes, time and temperature CLCD by using display modes like a time or temperature. They display this type of modes. And coming to the matrix keypad, it is nothing but we want to enter some values like a time, how much time you want to uh, cook the food, and which temperature you want to cook the food, and that's it. And coming to the buzzer is it's like a alert system. If the food is over, if the food cooking is over, uh, and the microwave oven gives the alert, nothing but a buzzer. This is the block diagram. And coming to next one, and the microcontroller architectures. In the microcontroller architecture, we have two architectures: non-human architecture and Harvard architecture. Uh, Coming to non-human architecture, it is uses a single memory for program and data storage, and sequential instruction execution, simpler design but slower due to memory bottleneck. His memory is like a bottleneck, so that's why his design and operation is slower. And coming to Harvard architecture, separate memory for program and data storage, and parallel instruction execution, faster performance and commonly used in embedded systems. Compared to both of these, we prefer Harvard architecture. And coming to next slide, it's a MPLAB IDE and development environment. MPLAB IDE is a comprehensive development tool for PIC microcontroller, and XC8 compiler is a compiler for 8-bit microcontrollers, and PIC Simulator, a tool for simulating PIC microcontroller projects, and PIC16F877A microcontroller overview. Its overview is coming to architecture, it 8-bit RISC architecture, and features 33 input-output pins and multiple timers, ADC, analog to digital converter, and SPI by I2C and UART. And coming to applications, it's a motor control, industrial automation, sensing, interfacing. These are the applications for microcontroller overview. And coming to next slide, it's a microwave oven. What is microwave oven? We see in the slide. Microwave oven, also called electronic oven, appliance that cooks food by means of high frequency electromagnetic waves called microwaves. So microwave frequency is nothing but is in the form of gigahertz, and a magnetron takes electricity from the power outlet and converts it into high power during cooking. And we are going to implement three main modes in this microwave oven. And the first one is micro mode, and the third one is and the second one is grill mode, and the third one is convection mode. See the micro mode. This mode is used to cook food in traditional manner. The maximum power of it is 900 watts. And coming to grill mode, this mode is used to cook meat and bread. User can set timer as per cooking time of the food. Convection mode, in this mode, user can set the oven to preheat for a particular temperature, and takes up to 3 minutes to preheat the oven. Okay, and after preheating is done, then user can set the timer as per the requirements. After preheating, the user can set the time as per the requirements. Requirements of the food is nothing but like that. And coming to requirements, we have software tools like MPLAB IDE, X8 compiler, PICSimLab, hardware components of PIC16F877A and 16x4 SELCD, tactile switch, and MKP timers two are used in this project. And coming to PICSimLab architecture. In this architecture, this is the circuit in PICSimLab. It is the output of the image, and it can operate up to 20 MHz frequency. Operating voltage in between 4.2 to 5 voltage. 5.5 volts, not 5. Yeah, it does not have an internal oscillator. It doesn't contain any internal oscillator, and maximum current each port can sink or source is around 100 milliamps. Each port in this source is around 100 milliamps it produces, and contains 40 pins and 8-bit controller. It contains 40 pins and the 8-bit microcontroller. And yeah, and coming to the softwares used, nothing but tools: PixSimLab microcontroller simulator, and MPLAB XIDE PIC development environment, and X8 compiler, C compiler for PIC MCUs, and CLCD simulation display the operational stages in the microwave oven, and PIC microcontroller with the PIC 16 of 877A. Powering on microwave oven, and check whether the board is PGNS board, and the microcontroller is P6F877A. Click on the file, load hex, file microwave, and oven.x. Open it, and you can see the powering on the screen. In the text, it shows the users to select the different types of cooking modes. The different types of such as micro mode, grill mode, and convection mode, and start mode. And let us start the first mode, micro mode. Press 1. The power is equal to 900 watts. Then it allows user to set time. The time is set 56 seconds. We can, and when the sex field is blinking, and we can clear it, and let us fix for 12 seconds. We are moving time minute field. This field is now blinking. Let us clear it. Let us start the cooking by pressing the hasher symbol. Now we can see the time is down counting. We can pass the cooking by pressing 5. We can start the cooking by pressing 4. We can also start the cooking by pressing 6. Now the cooking is being stopped. Next here comes the second, the grill mode. Let us press 2. It allows the user to set the input, write the time. Let us click for 12 seconds. And minutes has 1 minute 12 seconds. Let us clear it. Let us clear the minute field. See what happens when the time is completed. It shows time up. Wait for it. Time up. Enjoy your meal. Next we are going to see about the third mode called the convection mode. Let us press 3. It allows user to set the temperature. I am setting the temperature as 120 degrees. Uh, 200. Okay, I'm letting it as 200. Enter. And press enter. Next here the preheating screen comes in picture. By default we are given the preheating time as 60 seconds, so the preheating happens by the time counting, the down counting from 60 seconds. Let us wait for 1 minute till the preheating happens. Yeah, 20 seconds more. Yeah, now the preheating is being completed. It tells the user to set the time. Let us give it of 5 minutes. Let us clear it. Uh, yeah, let us clear it. Let us give off 1 minute. Let us enter the 1 minute of time, cooking time. The time start down, counting, and which indicates a fan or TV turned on. Here also the same pass operation can be done by pressing 5 and resume. Let's wait until time starts down, counting to 0. Still 20 seconds more. Now 10 seconds. Completed. Time's up. Enjoy your meal. Now micro mode, grill mode, and convection mode is done. Last one is remaining, the start mode. So we can start 4 in start mode. Let us click on 4 to view the start mode. In start mode, it automatically starts down counting from 30 seconds. By pressing 4, we can extend that 30 seconds from the down counting. Now you can see here, now it is 13 seconds, not. Yeah, 1 minute 9 seconds, 1 minute 7, 1 minute 34, 2 minutes, 60 seconds, and now 1 minute 20 seconds, 23, and press 5, and press 6, and the final conclusion. uh, Through this entire project internship, I gained a deep understanding of embedded systems, from the foundational role of C programming to the practical implementation of microcontrollers and peripherals. Simulating a microwave helped me to connect theory with real world applications and appreciate how embedded systems power with the devices we use every day. And this experience not only strengthened my technical skills but also uh, gave me a confidence in designing and debugging embedded systems using tools like uh, MAB, MXB IDE, and Pixlink Lab Simulator. And thank you for your time and attention. I hope this presentation give you a new perspective on how embedded systems quietly shape our daily lives, one smart application at a time. I'm happy to take back your feedbacks and questions in comment section below. Thank you.